How does a nuclear power plant work? This is where nuclear leakage occurred at a Japanese nuclear power plant. These are nuclear fuel rods. Inside them is uranium-235. Don't underestimate these small rods. They generate heat equivalent to 200,000 liters of oil. This heat is used to generate electricity, is enough for an average household to use for 100 years. So, how does it generate electricity? And why can workers handle them safely? And what's the deal with Fukushima's nuclear wastewater? You'll understand all of this after watching this video. These black powders are the refined uranium-235. It's compressed into solid cylinders using heavy tools. This process is called sintering. Afterward, they are baked in an oven on a conveyor belt. This process is called baking. A layer of ceramic material is added for protection, providing physical protection, increasing radiation shielding. Next, these baked pellet columns are loaded onto trays and arranged neatly in rows, convenient for loading into these fuel rods. These fuel rods are made of zirconium metal. Zirconium has a high melting point, corrosion resistance, and good thermal conductivity. So they're widely used to encase nuclear fuel. The process of loading nuclear fuel particles into metal tubes is entirely automated. Nuclear fuel contains uranium-235 or 238 and plutonium-239, among others. However, for economic reasons, most plants use uranium-235. Tubes containing nuclear fuel are transported to an automatic welding machine. Each fuel rod is welded shut. Then, they are moved to a fixed device. A bundle of fuel rods consists of 37 rods. They're vertically aligned for standard uranium content. Because before they're sent to the reactor for fission, their radioactivity is very low. Their metal or ceramic casings provide radiation shielding. Workers also follow safety procedures, so there's no issue. Once processed and packaged, they head to the power plant. So how does the plant utilize these rods for electricity? This is what you often hear referred to as the nuclear reactor. The container, these cylindrical tubes, they're the fuel rods that were just delivered. They'll produce nuclear fission here to generate electricity. But why doesn't it explode like an atomic bomb? The nuclear fuel in an atomic bomb is densely packed. This causes an uncontrolled chain reaction. Unlike the controlled structure of nuclear power plant fuel rods, designed to be long and slender, with sufficient gaps between them. To prevent uncontrolled fission, also workers follow safety procedures. So there's no risk. After being processed and packaged, the next step is to transport them to the nuclear power plant for electricity generation. This slows down nuclear fission. The main reason is, inside the nuclear reactor vessel, apart from nuclear fuel rods, control rods are also inserted. They are made of materials like boron chromium or thorium. Their important feature is their ability to efficiently absorb neutrons. Adjusting their depth controls neutron absorption. This allows us to regulate and control the strength of the chain reaction. The principles of nuclear fission have been explained in previous atomic bomb videos, so I won't go into detail here. To put it simply, nuclear fission produces thermal energy. This heat is absorbed by water in the container, which helps prevent overheating. This is where the control rods come into play. We can control the number of neutrons and thus the intensity of the reaction. Red boosters increase container pressure for added safety, raising the boiling point of water to over 300 degrees. This prevents the water from boiling inside the container. The hot water inside the container is pumped through pipes to an evaporator for recirculation, back to the evaporator. It is cooled by passing through closed cooling pipes, without direct contact with the water inside the evaporator, because the evaporator operates at standard atmospheric pressure, so the water easily boils and vaporizes inside it, generating high-pressure steam. To generate power, the high-pressure steam produced in the process is directed through a steam pipe to a steam turbine. This steam then drives the turbine, similar to how a pressure cooker works. When water boils, it produces high-pressure gas. This high-pressure gas is used as a driving force to rotate the turbine, and the rotating turbine drives the generator. The electricity generated is then transmitted through substations and power lines for distribution. Finally, the process returns to the steam turbine. The steam, now devoid of energy, is directed to a condenser. High-temperature steam encounters the condenser's cold pipes. The steam condenses back into water and is then pumped back to the evaporator for recycling. The water in the condenser pipes is sent to a cooling tower for cooling. Now, you should understand what the nuclear contaminated water released by Japan is, right?